In this video, I'm going to talk about some of the basics of isotopes. We have a nuclear symbol that looks, We have a nuclear symbol that looks like this. The X is the symbol of the element. The A is the mass number. And that's the number of protons plus neutrons. And the Z is the atomic number. And that's the number of protons. And we know that protons defines what the element is. So the definition for an isotope is an atom of the same element that has different numbers of neutrons. So we'll go through the 3 isotopes of hydrogen so you can kind of get an idea of what I mean, and then different ways to write these isotopes. So what we have here, this is just the nucleus of an isotope of hydrogen. I'm not including the electrons here. So this isotope of hydrogen, we just have a proton in the nucleus. And we call this, the common name would just be hydrogen. If we want to get a little bit more systematic about it, we'd write hydrogen dash 1. And this 1, what it's telling you is how many protons plus neutrons are in the nucleus. And if we wanted to write it as a nuclear symbol like this up here, we would write the H, and then the 1 up top, and the 1 on the bottom. Now, we don't necessarily really need to write this bottom 1 because that's just telling us the number of protons, but since we know we have H, we know that we're only dealing with 1 proton. So sometimes that bottom number is left off. Okay, let's move on to our second isotope of hydrogen. Notice what's changed here in the nucleus. We still have the 1 proton, but now we also have a neutron. So common name for this would be deuterium. But if we wanted to write it more systematically, we'd write hydrogen dash, and now we have a proton and a neutron in the nucleus, so hydrogen 2. And then nuclear symbol, we'd write the H with a 2 on top and a 1 on the bottom. Our third isotope of hydrogen, again, we've just added another neutron. And the common name for this is tritium. Systematically, we would say this is hydrogen 3. Again, because we have 3 subatomic particles in the nucleus. And then finally, nuclear symbol would look like this. Okay. So we have some examples here, and we want to take these systematic names for these isotopes and write them in the nuclear symbols. So let's try our first one, boron 10. First thing, we need to write down what is the symbol for boron. Well, it is just a B. And we can look on the periodic table, find the symbol for boron B, and see that boron is the 5th element. So that means we should have a 5 as a subscript. And then this 10 here is telling us protons plus neutrons, so that goes up top. Remember the names for these. This is the mass number. This is protons plus neutrons. And then this is the atomic number, which is just protons. So if we were interested in figuring out numbers of neutrons, we could just subtract the 2, and we get number of neutrons. Okay, boron 11. We want to think about what's going to change from this symbol here. So we still have boron. It's still that same compound, or that same element, sorry. And if we know it's boron, then we know that it definitely has 5 protons. So the only thing that's going to change is this number up top. So boron 11, its symbol would look like this. Let's try the next one, sulfur-32. So the symbol for sulfur is S. Look on the periodic table. We see it's the 16th element, so that means it has 16 protons, so its atomic number is 16. And then mass number goes on top, 32. Now, if we were to change it to this sulfur 33, the only thing we'd have to do is change this 32 to a 33. If we were going to do sulfur 36, the only thing we'd have to do is change that 32 to a 36. Okay, let's try our lead example. The symbol for lead is Pb. We look on the periodic table and we see that lead is the 82nd element, so that means it has 82 protons, so that's telling us our atomic number. And then if we do the first isotope of lead, we would put 204 at the top, and again that's protons plus neutrons. If we were to change this symbol into the second lead isotope, all we would have to do is change this 204 to 208. So here we have a chart that I would like you to try filling out. I'm missing up top what actually I'm looking for here. So in this first column, what we're looking for is just the element's name. So just the element name. In this second column, we're looking for the symbol. In this third column, we're looking for the nuclear symbol. And actually, one of the nuclear symbols is missing. Right here, I had Hg 202 here and 80 right here. Okay, and then right here we're looking for the atomic number, which is Z. Here we're looking for the mass number, which is A. This column I'm looking for the number of protons. This column, number of neutrons. This column, number of electrons. So I'm going to go ahead right now and do the first row, and after you kind of see how to do it with the first row, I want you to pause the video and try the next 4 on your own, and then come back and see if you got them correct. Alright, so first row, what we're given is the element symbol. We're told it's Mn, and we're told it has 31 neutrons, so we have to fill out all the rest of this information from just those 2 pieces of information. So first one, Mn. That element's name is manganese. So it's M-A-N-G-A-N-E-S-E. Manganese. Nuclear symbol. Let's just start it, but we won't be able to get the entire thing right now. So we definitely know the X will be Mn. But we don't know the A or the Z. So we don't know the superscript or the subscript yet. So we'll skip that for now. Let's go on to Z. So Z is the atomic number, which is the number of protons. And if we know we're dealing with manganese, we look on the periodic table and we see it's the 25th element. So our Z is 25. And since we know that, we now know the bottom piece of our nuclear symbol. And also, we know the number of protons, because Z is the atomic number, which is the number of protons. And right now, we're just dealing with neutral elements. We're not dealing with ions. So however many protons we have, that's how many electrons we have. So notice, this column and this column and this column are the same as is this right here. They're all the same thing. They're all telling you the same thing. Okay, the A is the mass number, and that's telling you the number of protons plus neutrons. So we have to add these 2 values together. And when we do that, we get 56. Alright, so go ahead and pause the video and see if you can get the next 4 rows on your own. Okay, so the table's all filled in now, so we're going to go through and just talk about the next 4 rows very briefly. So we see we have carbon. We know that the symbol for carbon is C. So that gives us this, and it gives us this component of our nuclear symbol. The reason why we can figure out that Z is 6 is because we look up carbon, we see it's the 6th element. So that gives us this piece, it gives us this piece, it gives us the number of protons. Those are all saying the same exact thing. And it also gives us number of electrons, because we're dealing with neutral atoms right now, so protons equals electrons. Now, the way we got neutrons to be 6 is not necessarily because protons was 6. The way we got this is we did the A, which is protons plus neutrons, minus the Z, which is just protons. So 12 minus 6 is 6. Okay, next one. We were given the nuclear symbol. I had to write that in because it didn't show up when I downloaded this, but we were given this nuclear symbol. We know that Hg is mercury. Again, we look up Hg on the periodic table. We see it's the 80th element, so that's how we get this Z. That's how we get this subscript here, and that's how we get number of protons. The A of 202, again, we were given this symbol here, so this is A. It's telling us protons plus neutrons. So now that we know protons plus neutrons, and we know protons, we can subtract the two to get the number of neutrons. And again, we're dealing with neutral atoms, so the number of protons equals the number of electrons. Okay, next row. So you'll see we've already done one with carbon, but notice what the key difference is here. In this carbon, the first one, we had a 12 up top. So that's saying that we have 6 protons and 6 neutrons. But down here we have 13. Now we're still dealing with carbon, so we know that we still have 6 protons. So what that 13 must mean is we actually have added one more proton or one more neutron to this. So these two carbons are isotopes of one another. So they are different, and it's because of the different number of neutrons. Okay. Last row, we have a Z of 29. So that's telling us number of protons, which is giving us the identity of the element. We look at the 29th element and see that it's copper. So we're able to write down copper, Cu, and then the Cu here. 29 comes from the number of protons. We were also given the mass number, so that's how we get the 65. We know that number of protons is the same as the Z. And then we got the number of neutrons by doing A, which is protons plus neutrons, minus Z, which is just protons.